Good evening and good morning to those in Asia and the other part of the world. My name is Melissa Withers, and I am delighted to welcome you to our third webinar. So this webinar series is organized by the APRU Global Health Program and sponsored by the USC Institute on Inequalities in Global Health. I'm the director of the program, and I will be the moderator for this evening or this morning. So this is the third webinar in our weekly webinar series. Thank you everyone for joining. Today's webinar topic is Environmental Factors and COVID-19, Preliminary Findings from China. And our speaker is a very distinguished professor, Haidong Kan, from the School of Public Health at Fudan University. And I just wanted to let you know that Professor Kan obtained his PhD degree from Fudan University in Shanghai, China in 2003. He did a postdoc training at the National Institute of Environmental Health Science in the United States. He's currently a distinguished professor of Cheung Kong Scholars Program by the Ministry of Education in China and a member of the China National Advisory Committee of Environment and Health, and is also an associate editor of the International Journal of Epidemiology. His research focuses on how ambient air pollution and global climate change affect human health. So it's perfect for our series. I just wanted to say a couple of quick things before we get started with his talk. I wanted to introduce, for those of you who are not familiar with APRU, APRU is the Association of Pacific Rim Universities. It's a nonprofit network of more than 50 leading research universities in the Pacific Rim region. It's been around since 1997, and the Secretariat is based in Hong Kong. The Global Health Program is housed at the University of Southern California in Los Angeles and was established more than 12 years ago. As I mentioned, I'm the program director of the Global Health Program, and really the aim of these webinars is to showcase the expertise of our members and to respond to the pandemic from various perspectives and disciplines and nations as well. So once again, thank you for joining us. A couple of housekeeping information. If you want to know more, if you would like to read Professor Kan's bio and look more at the webinar, please visit the website. We'll type it right there in the chat box, but it's just apruplus.org. You can also check out apru.org for more information about the APRU, and apruglobalhealth.org if you want to learn more about the Global Health Program. In addition, we will be sending everyone these slides and recording for those of you who registered, but please also share the webinar widely now through social media at Facebook at APRU 1997 or hashtag APRU+. And let's see, what else? I wanted to also remind you that we will have time afterwards to be able to interact with Professor Kan. So please put any questions, type them into the Q&A box, and I will be reviewing them, and we'll have time of 20 or so minutes at the end. Please include your name and institution where you are so that I can ask him our questions. So I guess without further ado, please welcome me in, please join me in welcoming Professor Kan.
Thank you. Thank you. Thank you so much. I'm going to share my screen. Melissa, can you see my screen?
Yes, thank you. Yes,
okay, so
perfect.
It's good. Okay, thank you so much for the introduction. My name is Haidong Kan. I am located in Shanghai, China, from School of Public Health, Fudan University. So it's an honor for me to talk here to talk about some preliminary findings on environmental factors and COVID-19 in China. So this is the outline of my talk. First, I'll introduce some background information of COVID-19 and the environmental issues. Then I will talk about our data and our methods to analyze the data. And for the results session, I'm going to go over the association of weather condition with transmission of COVID-19, air pollution and transmission of COVID-19, and the air pollution and the fatality rate of COVID-19. Finally, a very brief discussion and summary. So this picture actually was from Johns Hopkins University, and we can see that as of yesterday, there have been more than 8 million cases of COVID-19 all over the world, and there are over 400,000 days of COVID-19 related days. So the World Health Organization has declared COVID-19 is already a global pandemic. And I think the disease composed the biggest challenge for our human society since the Second World War. So this picture shows the different temperature trend at the major countries. Here we can see that for the European countries like United Kingdom and Germany, I think the daily new case has been declined and the disease has been under very well control in Europe. But for the country, Brazil and India, you can see that the daily new confirmed case has been still increasing very, very fast. And for the United States, the daily new case has been remained stable for quite several weeks. So the disease is still a big challenge for our world. How about the situation in China? This is the total confirmed COVID-19 case and the total confirmed COVID-19 deaths in China. We can see that the disease, I think, the outbreak was in Wuhan in the middle of January. And at the beginning of this March, I think the disease has been under very well control. Regarding the days, you can see that in early April, there was a change of the definition of COVID-19 related days in China. So you can see that the total confirmed days number in China increased a lot in the middle of this April. So here, this is the spatial trend of COVID-19 in different parts of China. The first outbreak was in Wuhan, Hubei Province here. And you can see that the Wuhan city is located in center of China. This is the center for traffic in our countries. So since the outbreak was in the middle of this January, which was the Spring Festival in China, so the joint traffic communication has helped the disease spread all over the countries. but still Hubei Province accounts for about more than 50% of total case in China. The right picture shows the current case. You can see that currently Beijing is the hotspot. For other provinces, there are very, very few cases of COVID-19. So this is a very recent outbreak of COVID-19 in Beijing from the beginning of this month. And from the left picture, you can see that in Beijing, it's already summer. The temperature is often over 36 degrees. So it's very hot in Beijing now, but still there was an outbreak half a month ago. The hotspot is in Xinfadi farmer market. Xinfadi farmer market is very famous in China because in terms of size, it's the #1 food market in the Asian region. A lot of people work and buy food there. So this epidemic happened in Beijing, bring a lot of public attention in our country. But the good news is yesterday, the China CDC had just announced that after their data analysis, they think the recent outbreak in Beijing has been under control, and they believe the daily new case in Beijing will decrease very, very fastly. Let's go back to our issue, environment and COVID-19. Actually, several months ago, I mean, in this March or in this February, a lot of people believe that temperature had a big effect on the transmission of COVID-19. Here, I just give you 2 examples. For example, the left picture shows a report that map the COVID-19 outbreak in some regions. And it's clear that it's very interesting that the major city with outbreak of COVID-19 is almost at the same latitude, 40-degree latitude. So the left picture shows some kind of clues to see the temperature or the location, latitude, longitude may have effects on the spread of the disease. And even President Trump of the United States also says that the weather has effects on the spread of the disease. He believes, at least in this February, he believes the weather starts to warm and the virus hopefully will become weaker and then go. But very sadly, it's not true. The disease nowadays has spread all over the world. So I think here, the key scientific question is COVID-19 sensitive to temperature and environmental conditions? I'm going to go over the literature to answer this question. Influenza is like COVID-19. Influenza is also a respiratory infectious disease. So a lot of publication, a lot of scientific literature have been published about the relationship between influenza and temperature, relative humidity. And this is an animal-based study published 13 years ago. And from this study, influenza virus transmission is dependent on relative humidity and temperature in guinea pigs. And we can see that from the right pictures that for different humidity like 35% and 80%, the percent transmission is totally different. It looks like the low temperature and the low temperature and the lower relative humidity is very important for the transmission of influenza virus. And the relative humidity is even more important than temperature for the transmission of influenza virus. This is animal-based evidence. And 2 years ago, there was a paper published on Science. This is a human-based study. It's a real-world evidence. That study finds that urbanization and humidity shape the intensity of influenza epidemic in the US cities. And according to that study, humidity is a very important determinant of influenza transmission among our human society. Also, COVID-19 COVID-19 is very similar with SARS, happened in the year 2003. This slide shows a study about the relationship between temperature and SARS epidemic in the year 2003. And it looks like SARS is a temperature-dependent disease. From that study, the cold temperature increased, the low temperature increased the SARS daily new case number, and with high temperature, the daily new case of SARS decreased very, very fastly in Chinese cities. Let's go back to the COVID-19 virus themselves. This is an environmental study about the stability of SARS-CoV-2 virus in different situations. Actually, the virus is highly stable at low temperature, like 4 Celsius degree, but it's very sensitive to heat. At 4 degrees, there was only, the virus could be viable for 14 days. But when the temperature increased to 70 Celsius degree, the time for the virus inactivation was reduced to 5 minutes. So here, this study shows that the virus is stable at low temperature, but at very high temperature, like 70 Celsius degree, the time is very, very, very short, for inactivation. And this study is the environmental conditions on the virus stability in human cell. And in human tissues, the virus is also more stable at low temperature and low humidity conditions, and warm temperature and high humidity shorten the half-life of the virus. In addition to temperature, air pollution is another issue which may affect the transmission of the disease. So I just list 2 publications about air pollution and the SARS. 17 years ago, there was a paper. It's a cross-sectional analysis about air pollution level and the SARS fatality rate in different Chinese cities. As you know, China and India have the worst air quality in the world. And during the SARS epidemic, in different Chinese cities with different air pollution level, the fatality rate of SARS differed. So this is a cross-sectional analysis, and the authors, I think the authors is from UCLA, and they did find there was a very good correlation between the mortality rate of SARS and the air pollution level in Chinese cities. So that cross-sectional study is from the spatial temp trend analysis. Another study was conducted by myself, and I did a time series study about air pollution and daily fatality rate of SARS in Beijing. And I did find that for different air pollutants, we find PM10 and the nitrogen dioxide NO2 had significant effects of daily death risk of SARS in Beijing. So that's the background information about environment and COVID-19. Then I will move to the data and methods part. So our health outcome data was collected from the national central government and the province health government. And actually the Chinese government, I mean, from at both central and the local government, they publish the daily case of COVID-19 on their website. Also on the internet, it's very easy for everybody to find the COVID-19 new case every day on the internet. You can find the daily new case, daily new days on the internet. So the data, I think, it's very public available. For the weather conditions, we collected the weather condition data from the China Meteorological Data Sharing Service System. And also for UV radiation, for UV radiation is not a regular parameter for the China Meteorology Data Sharing System. And we collect data using the method is from the satellite data. We collected the data from OMI satellite. And also we collected the air quality data from National Air Quality Monitoring System in China. I think so far, China maintains the largest air quality monitoring system in developing countries. In China nowadays, over 300 cities, there are more than 1,400 air quality monitoring stations. And nowadays, there are 6 criteria pollutants in China: PM2.5 or fine particle, PM10 or coarse particle, ozone, SO2, NO2, and carbon monoxide. And this is the statistic measures. We collected cumulative number of confirmed cases from over 200 Chinese cities with more than 10 cases. And also we calculate the basic reproduction number, or R0, for over 60 cities with more than 50 cases as of February 10, which was a peak time for COVID-19 in China. Here, I just want to introduce R0. R0 means expected number of secondary cases generated by initial infectious individuals in a completely susceptible population. So if R0 less than 1, it means the daily new case will become smaller and smaller. The disease has been under well control. If R0 is more than 1, then the disease, this daily new number case will increase, and the disease is on outbreak. We conducted a spatial level cross-sectional analysis in various Chinese cities. We examined weather conditions and transmission rate. We examined air pollution and transmission rate. And we also examined air pollution and fatality rate of COVID-19 in China. So this is our first finding about weather conditions and COVID-19 transmission in different Chinese cities. Actually, we already published our paper on European Respiratory Journal. And actually, we did not find a significant association of weather conditions with R0 of COVID-19 in Chinese cities. For temperature, no association. For relative humidity, no association. For UV radiation, also no significant association. So if you want to go into the details, please refer to our published paper here. I'm going to talk more about NO2 and the transmission of COVID-19. This is the NO2 concentration for the 63 Chinese cities and the R0 values for these cities. From the right picture, we can see that here we list the NO2 level in Chinese cities in the past 5 years. And we can see that due to the lockdown policy, due to the social distancing policy, the NO2 level in China decreased a lot, compared with the previous years. And here is our findings. The right picture shows the correlation of R0 of COVID-19 with different air pollutants. For PM or SO2 or CO, we did not find any significant association. We only find significant association of COVID-19 transmission with the pollutant NO2 or nitrogen dioxide. And that's the only pollutant we find significant association with the transmission of COVID-19. We also examine air pollution and COVID-19 fatality rate. Here, this slide shows the different death rate of COVID-19 in different parts of China. We can see that the highest death rate was detected in Hubei Province, was detected in Wuhan city. But for the other province or other parts of China, I think the death rate is much smaller compared with Wuhan. So the right is a NISA cluster map, which shows the spatial trend of the death rate. This is the PM level during epidemic in different parts of China. We can see that for PM, I mean, for Hubei Province, the PM level is a little bit higher, I mean, compared with other parts of China. Here is the association between PM and COVID-19 fatality rate. For both cities outside Hubei Province or cities inside Hubei Province, we find significant association between PM and COVID-19. For PM, we find the association for both fine particle and coarse particle. So this is the regression results. If we use the PM level during the epidemic period, we find significant association outside of Hubei. And for the cities inside of Hubei, the association was not significant. But if we combine the cities outside and inside of Hubei, the association, the results is still significant. We also examine the health outcome with different exposure period. If we use the long-term exposure period of PM as the exposure, we still very similar results. We find significant association for cities outside Hubei and the whole China. This regression results has already adjusted for GDP per capita and hospital base per capita and other confounders. We also did some sensitivity analysis for cities outside of Hubei Province. For the main model, we find significant association. In addition, we also adjust some kind of spatial autocorrelation values. We further adjusted for city size and population size. We adjusted for proportion of people, for the percentage of the old people. Still, I think the results were pretty stable or robust. Here is some discussion. For the association between weather and transmission of COVID-19, actually we did not find any significant association. I think that these results are under my expectation. Recently, there was a very good paper published on Science just 1 month ago. I think this is from a group from Princeton University, and this is a simulation study among human society. And I think the conclusion is very interesting. According to that paper, they said that during pandemic stage of no new disease, the climate drives only modest changes to pandemic size. Without effective control measures, strong outbreak are likely in more humid climate, and summer weather will not limit pandemic growth. So I think for a disease like COVID-19, which is a normal disease for our human society, weather or other environmental conditions might not a substantial determinant of the transmission of the disease. For a society, almost everybody is vulnerable to the disease. Weather conditions might not be that important. And we also find a significant association between NO2 and R0 of COVID-19. I think there are two explanations for that association. First is from biological mechanisms, ambient NO2 was found to affect human susceptibility to influenza virus. And in 1990s, there are a lot of papers published by the US scientists showing the effects of NO2 on human response to influenza virus. I think the same thing may happen for COVID-19 virus. And another explanation for NO2 is, NO2, as you know, the major source of NO2 is from traffic. So NO2 can act as a map of traffic and population movement. So another explanation or hypothesis is, for the cities with high population movement, the transmission of R0 of COVID-19 is high. And for the lower NO2, or also lower population movement, the transmission of the disease is also lower. So that's another explanation for our observed association between NO2 and transmission of COVID-19. The third finding of our study is we find the significant association between ambient PM and death risk of COVID-19. Actually, in recent months, there have been a lot of papers published about the association between PM and the death risk of COVID-19. Here, I just give you two examples from the US. This paper was published by Francisca Dominic group from Harvard University. And this is a very good, here I just give the reference information here. This is a very, very well-written paper about PM and the mortality risk of COVID-19. And they did a very excellent data analysis about PM and the death risk. And they did find association between PM and the risk in the US, the death risk of COVID-19 in the US. Another study is from Emory University, and the different thing is compared with the previous study is they find significant association for NO2 instead of PM2.5 with the death risk of COVID-19. And in addition to the US, in other countries like Italy, in like European countries, or also in China, different groups have also found air pollution level, especially PM, may affect the death risk of COVID-19 patients. So finally, just give some very brief conclusion. I think so far, warm weather might not reduce the transmission of COVID-19. It might be premature to count on warm weather to control the disease. So that's our first preliminary findings. The second finding is we find a positive association between ambient NO2 and transmission of COVID-19. There are two explanations for that. The first one is NO2 might increase human susceptibility to virus infections. Another explanation is reduced population movement can reduce the spread of the disease. The third conclusion is we find positive association between PM and COVID-19 death risk. I think the relationship is pretty robust, and the finding has already been replicated in other parts of the world. So that's all about my talk. Finally, I would like to thank for your attention and thank APRU to give me the opportunity to share our findings on the environment and COVID-19. And thank you very much. I would like to take questions. Thank you. Hi, Melissa, I finished.
Thank you so much, fantastic. And the questions are coming in. So why don't we start, let's see, with the first one. This one comes from Heather in the United States. Based on these results, would we expect to see an increase in COVID mortality as pollution levels raise as economies reopen?
Oh, this is a very excellent question. I think air pollution is just one determinant of COVID-19 mortality. And probably air pollution is not the most important one. I think our knowledge about the disease is increasing very, very fast. I believe the air pollution level itself might raise after economic reopen, but I don't think the mortality rate will increase at the same time because our knowledge on the disease has been advancing very, very fastly.
Great, okay. Next question comes from Shuka from Tohoku in Japan. And that is, do you think the relationship between air pollution and COVID-19 is the same in other countries?
Yeah, I think for our finding about air pollution and the mortality risk of COVID-19, I think the relationship is pretty robust. It has already been observed in other countries like in the United States, like in the European countries. But for the finding about the transmission rate of COVID-19 and the air pollution level, I think there are still a lot of open questions for that association. I think more evidence are needed to confirm the association between air pollution and the transmission of the disease.
Okay, thank you. The next one comes from Francis. Hello, Francis, from the United States. In your statistics, does asthma prevalence parallel COVID severity?
Oh, this is a clinical related question. I don't have the data. I'm sorry for that. Probably I will ask my colleague. Yeah. Okay,
no problem. Okay, this comes from Ying. Hello, Ying. Zhang, is she what is involved in the environmental health group within APRU Global Health Program? She says, thanks, Professor Khan. Do you think the non-significant relationship may be due to the very strict COVID control measures in China?
Yeah, that's a very good question. I think a strategy to tackle this question is to use the very beginning period of the outbreak to study the relationship. At the very beginning period of the epidemic in each country, the control policies, there is almost no control policy. So we can catch up that special period to study the relationship between temperature and the transmission of the disease. So, with that strategy, I think we can observe the association with more clear evidence, I think. Yeah, I will take a look.
Thank you so much. The next one comes from Daniel in the Philippines, who asks, who says, we are a tropical country and it's super hot here. Why did the virus make it through our country?
Yeah, that's mysterious. Yeah, this a very good question. I think, yeah, several months ago, people think that the disease will not affect the country with hot weather, but nowadays it's very clear it's not true. I think for a novel disease like COVID-19, I think everyone in human society are vulnerable to the disease. So in that case, I don't think temperature is the very important determinant of the disease. But I think for disease like influenza, or which has a lot of people already has antibodies inside humans. So for that kind of disease, weather conditions is important. But yeah, for novel disease like COVID-19, I don't think weather is as important as other issues.
Okay, the next question comes from Fevi, who is from the Philippines, who says, thank you, Dr. Khan, for an interesting presentation. If ambient temperatures have no significant association with COVID-19, what do you think could have been the most common environmental factors among those colder countries with highest cases of the disease? Do you want me to say it again?
Yes, I'm reading the question.
Okay.
Okay. So I think for the highest case of the disease, for the countries with the highest case of disease, I think social distancing is still the number one determinant of the transmission of the disease. I mean, in a broad definition of the environmental factors, like social distancing or human contact, I think they are the most important factors affect the transmission. But for temperature, and air pollution, they are not important. To determine the transmission of the disease.
Perfect. The next question comes from Sarong. Could you simply say that COVID-19 is strongly associated with PM value because it's a pulmonary disease?
Yeah, that's true. That probably is true, because there is very clear evidence between air pollution level and cardiorespiratory disease. So I think as also COVID-19 is also a respiratory disease, and COVID-19 affects cardiovascular systems. There is very clear evidence. So it's biological possible, for air pollution to affect the death risk of COVID-19.
Okay. By the way, I would like to give a shout out to my global health class who's here, my new global health class. So and my co-instructor. So if you're interested in asking a question, please don't be shy. Next question comes from Brian in Singapore, who says, thank you, Professor Khan from Yale and US College. Following Heather's question, is the increased COVID-19 mortality associated with nitrogen oxide due to long-term exposure, lung damage, or some other factor?
Thank you, Brian, for your question. Actually, the reviewer of our manuscript has raised the same question to us. Yes, we did a sensitivity analysis using the exposure from different exposure periods, from the epidemic period, from the exposure in the last year, in the last 5 years, and we almost obtained similar findings. We use different exposure metric, and we have similar findings to find the association between NO2 and transmission of the disease.
Okay, next question comes from Angus from Sydney. Hello, Angus. the PM data, et cetera, associated with COVID is really striking. Is this a sign of interaction between the two, or due to previous damage to lungs from PMs in the environment pre-COVID?
Yeah, look, this is a similar question. I mean, with previous NO2 question, I think we also for the PM mortality association study, we also did sensitivity analysis. We use PM during the disease. We use PM in the last year. We use PM in the last 5 years as exposure to explore the association, and we have almost very similar findings. I mean, we did find association between PM at different exposure period and the transmission rate R0 of the disease. So I agree with you that one explanation for our association is PM has already affected our cardiorespiratory health, which may make people vulnerable to the COVID-19 disease. Yeah, a supporting evidence is the evidence from smoking. You know, for the people with smoking, they have a relative high death risk compared with the people without smoking. So it's similar, I think.
Okay, thank you. Jervy asks, what is the basis for choosing spatial cross-sectional analysis for your study?
Yes, we choose the cities we choose city with over 50 cases in a city because we need to have stable estimation for R0 in that city. So only the city with over 50 cases are included in our study because we need to estimate the R0.
Okay, thank you. Emma from the United States. Yay, Emma. Could there be an association between population density and pollution? Are the regions of China with higher transmission and fatality rates the ones that have denser populations?
Thank you for your question, Emma. From the scientific literature about influenza, urbanization is a very important determinant for the transmission of influenza. I think similar thing will happen for the disease for COVID-19. And you are right that for cities in China like Beijing has a very high population density, and the air pollution level in Beijing is much higher, I mean, compared with other Chinese cities. And in our study on the association between PM and death risk COVID-19, we adjusted population density, population size as a confounder in our regression analysis. And I think we find that after including the confounder like population size, city size, we still find the association for PM. So I think the association for PM is independent of the population size or the city size.
And someone asked, do you think that has anything to do with why there was a high death rate in New York City?
Yeah, I think the high death rate in New York City is the New York City. I mean, for this outbreak, New York is like Wuhan. In China, similar things happen. In the city of Wuhan, most cases in China happen in Wuhan. And the problem is for the medical resources are almost exhausted. I think the similar thing happened in New York. It's not, I think the higher death risk COVID-19 in Wuhan and New York, it's not because of the environment, it's because of the availability of medical resources.
Okay, thank you. Amy from the Philippines asked, do you know anything about whether blood type has an effect on susceptibility?
Yeah, a paper has published on that issue. Yes, the blood type like A blood like type A is more vulnerable to COVID-19. I mean, compared with B or O type, blood type.
Thank you. Next question comes from Lin from Tohoku University in Japan. Thanks, Professor Khan. Do you think cultural differences are an interference factor for your research because COVID is totally different across different continents?
That's true. I think from a global perspective, I think the Asian countries generally has a better performance. I mean, compare with the other regions of the world. I think for the Asian countries, because they had experience with SARS before. So the Asian countries more cautious, I mean, with the respiratory outbreak diseases like SARS, MERS, or COVID-19. I think that's one reason why the Asian countries, like, especially the East Asian countries like Korea, Japan, China, Hong Kong, they have a better performance in control of disease compared with other parts of the world. I think our East Asian culture may play a very important role in it. I think more studies are needed to link, more studies needed to study the sociology part impact, to study the social structure or culture on the transmission of the disease. This is a very important and a very interesting topic to explore.
Yes, I agree. I was just talking this morning with a group that I've been so surprised about the backlash in the United States against restricting individual freedoms. It's been quite shocking to me as a public health professional. Yeah. Okay, let's see. Dr. Gibson from USC, thank you for a great talk. A bit of a policy question, and that's kind of where I wanted to go with the last few minutes as well. She asked, based on your findings, should there be efforts to integrate transportation or environmental control agencies into public health responses to COVID-19? And are there any discussions like this happening in China yet?
Yes, actually there are intensive discussion about the environment issues, the importance of environmental issues of this the pandemic. And in China, actually during the disease epidemic period, the NO2 level did decrease a lot, but for PM, there was almost no change. In China, we have a lot of discussion. Why is that? Why NO2 decreased a lot, but for ozone level or PM2.5 level increased in Chinese cities? So there are a lot of scientific discussions among the local community. Why is that? Also, the government has, I mean, in China, lockdown policy, I mean, the major lockdown policy is the restriction of transportation. And in January or February in China, actually there was no transportation at all in China. Everybody stayed at home. We know almost is closed down. So I think the policy, the transportation has already been integrated with the control policy in China. And for air pollution control, I don't think the government pays a lot of attention to that issue. But I think the scientific community has seriously considered this issue, and a lot of things I think is to be discussed in the future about this issue.
Yeah, so I guess I would ask, following that up, we hear so much about all of the terrible consequences and negative outcomes of COVID-19, but here we also have the opportunity to kind of highlight some positive environmental impacts or changes that we've seen as a result of these control measures. So what would you recommend to policymakers going forward, or to us, so that we don't go back exactly to the way things were before?
Yeah, I think everybody wish to go back to normal life, and but the truth is, it's true that, I mean, for environmental, I mean, for the emission of carbon dioxide, for the emission of air pollutants, the emission decreased a lot during the lockdown, due to the lockdown policy, which make the environment much better than before. So I think the pandemic provides a very unique opportunity, I mean, accountability study opportunity to examine the impact of the environment on health, on social, on the economic, on other issues. So I think we need to study, we need to scientific evidence about accountability study to link environment with a broad issue like health, like social economic, like other issues. I mean, to provide evidence for the policymaker about this.
Okay, we have time for maybe one or two more. Ava Merrill, who is head nurse at Hospital for Sacred Heart, Philippines. Do you think the type of governance and discipline of the people has something to do with an increase or decrease in numbers of cases?
Thank you, Ava. This question is similar with previous question about culture. I think, yeah, for East Asian countries people, our culture is, if the government asks us to stay at home, we listen to the government commander and really stay at home. But for other countries, it's not the case. So that may explain the different transmission of the disease in East Asian countries or other parts of the world. So you raise a very, very interesting questions to take a look in the future. How culture, how sociology affects the transmission of a normal disease. Yeah, I think a lot of study need to be done on this aspect.
Yeah, so you Fan asked a similar question relating what's the cause of increased cases. And so maybe it is the fact that here in the US anyway, that you know, people are tired of being under quarantine, and
yes,
yeah, kind of backlash against wearing masks and closing bars and restaurants and all kinds of things. So, and then Nanita just, hello Nanita from the Philippines.
Hello Nanita.
She wanted to comment, the data shown and analysis are amazing, quite stimulating for future global health research in public health.
Thank you, Nanita.
All right, so I would like to thank you so much for taking the time to really provide insight into this really important topic and help us understand what, you know, the impacts of the environment on COVID-19. So thank you, Professor Kum, for being here.
Thank you, Renita.
And for our participants, our attendees, I just wanted to remind you that next week, same place, same time, we will have our next speaker talking to us. Dr. Jean Encinas Franco is from the University of the Philippines at Diliman. The title of her talk is Philippines Modern Day Heroes and COVID-19, talking about Filipino health workers abroad. So that should be a really interesting talk, and I hope that you all will join us. And once again, thank you to everyone for participating in this webinar. It was wonderful to have you all. Thank you.
Thank you.